Now, let's start writing code in doubly linked list. So, there are different methods that we are seeing when it comes to single linked list. So, same methods we are going to implement in the doubly linked list as well. So, the logic might remain almost same, but not exactly like how it was in single linked list, because in case of doubly linked list, we have one more extra link called as previous, which we will have to connect as well. So, the first method that we are going to implement is nothing but the add method. So, what exactly does this method do? This method will actually accept a number and it will add that particular number into the doubly linked list. Now, how can we do this? So, when it comes to this particular situation of adding a number into a doubly linked list, there are two cases. One case when there is no element inside the doubly linked list, or I mean to say when the doubly linked list is empty. So, when it is empty, definitely the head as well as the tail will be pointing to null. Now, how can we add an element in this case is one case. And one more case is if we have multiple elements already inside the doubly linked list, how can we add the next element or whatever we are trying to add into this at the end of the doubly linked list. So, we will handle case by case, one after the other. So, the first case that I am going to handle is nothing but when there is no element inside the doubly linked list. So, in case of no element in the doubly linked list, both the head and tail will be pointing to null. So the first thing I need to do over here is create a node. So I am going to create a node and I am giving the name as temp. Now in that particular node there is previous as well as there is next. So previous also points to null, next also points to null. Now once I am done with this, what is the next thing that I have to do? I need to check whether the doubly linked list is not if there is element in the doubly linked list or not. Now how do I check whether there is element in the doubly linked list? Very simple thing. Either head will be pointing to null or tail will be pointing to null or both will be pointing to null. All I need to say is head pointing to null, or I can say is head equal to null. So that's what exactly I am writing over here as well, is head equal to null. If it is equal to null, it means to say doubly linked list is empty. And if it is empty, the new node that I have created, whichever I am calling it as temp, that's the node that will be there inside the doubly linked list. And that's the head and that's the tail, because that's the first node and that's the last node. So all I have to do is make sure head points to this node as well as tail points to this node. Now how do I make sure that both head and tail points to this node? Very simple. All I need to say is head equal to temp and tail equal to temp. So whatever is there in temp will be stored in head as well as it will be stored in tail. So basically head, tail and temp will be pointing to the same particular node. Now in this case, we are successful in adding a node into a doubly linked list. Now the second case is when there are already elements, how can we handle this? It is even more simpler. The first thing that I have to do is create a node. Once I am done with creating a node, now there is something that we need to observe in the diagram and then write the code. It's not about just thinking, it's just more about observation over here. Now what exactly should happen is, this node that I have created should be added at the end. Now if it has to be added at the end, what should happen is whichever node is there at the last already. So in our case 20 is the last node that we have. So in this particular node, what exactly has to happen is, there is something called as previous link and there is something called as next link. Next link is actually pointing to null. Now what I need to make sure is the next link of the last node points to the new node, and that's nothing but temp. Means next link of the last node should point to temp. If I have to do this, I need a reference for the last node. Now how can I get the reference for the last node? Very simple. We already have a reference called as tail, which will be pointing to the last node. All I need to say is tail.next equal to the next node, and that's nothing but temp. So whatever is there in temp, that's the reference of the new node, has to be stored in the tail.next. So how do I write this code? Tail.next is equal to temp. That's all. Not just that, now when it comes to this new node that I have created, in the new node there are two pointers. One is nothing but the previous and the other one is next. Since there is no element after this, the next will remain as it is, means it's null. But the previous one, since there is element before this, which is the element, the last one which was the last one, that is the element. So what has to happen is temp.previous should start pointing to the last node, means earlier which was the last node for that, and that's nothing but tail. So basically I mean to say temp.previous should start pointing to tail. So how do I write that? Just simple temp.previous is equal to tail. After this, now this is not my last element. This has become my last element. If this is the last element, then tail should not point to this particular node. Rather, it should start pointing to this particular node. Now, how do I make sure that it points to this node? Very simple thing I have to do. I need to make sure that tail points here. How? Because temp is already referring to this. So all I have to do is whatever temp is referring to, make sure tail also refers to that. So whatever is there in temp, store it in tail, and that's what I'm doing over here. Temp, whatever is there in temp, store it in tail. So basically, tail is equal to temp. So this is how I can write code for when there are already elements present in the doubly linked list, and when there is no element, we have already seen that. So all I have to do is just write if else condition. If head is null, it means there is no element in the doubly linked list, and I have told what has to be done. And when there is element, these are the 3 steps that are. This is all about the coding part of it. Now let's go and write the code and check whether it works or not. Now let's write the code for the add method. So inside the main method, I have already created a node, but I have not added it anywhere. So moving ahead, I won't be creating any node like this. Rather, we'll be directly calling the add method, and the add method will actually create the node. So all that I have to do is I will ignore this part as of now. Rather, I will go to the doubly linked list class and then write the code inside. So if I take you to doubly linked list class, you have 2 pointers. One is head and the other one is tail. So both are instance variables. Now all I have to do is implement the add method. So I'll come inside this and I'll create a method called as add. And it should not return anything. So it's void add. And it accepts one parameter, and that parameter is nothing but an integer value. So I'll say int, and it's nothing but element. So I'll say element. Great. I will open and I'll close it. Now, once this is done, the first thing that has to be done is, in both the cases, we have to create a node. So let me create a node by saying new node, and to this particular node, the parameter I need to pass is element. So I'll pass element over here. So I'll pass element, and I will store it inside a variable called as temp. I will name it as temp. Next, I'll come to the next line, and over here I need to check whether head is pointing to null or not. So in case if there is no element present inside the doubly linked list, then definitely head will be pointing to null. So I will just check that condition if head is equal to null. Great. I'll open and I'll close it. I'll come to the else part. I'll open and I'll close it. So when the head is equal to null, it means there was no element present in the doubly linked list. In that case, whatever I have created temp, that's only my head, that's only my tail. So I'll say head is equal to temp. Head is equal to temp. Same way, tail is equal to temp. Great. I'll open, I'll close. Then next I'll come to the else part. In case of else part, it means to say that I have already created, the linked list is not empty. So in this case, what I need to do is, whatever is there in the last node, so I have already written it over here. The last node is nothing but tail. So the tail dot next should start pointing to temp. So what I will do is I will say tail dot next equal to temp. So earlier tail dot next used to point to null because there was no element after this. But now there is a new element added after the tail. Now along with this, one more thing I have to do. Now I have created one node called as temp. So the previous part of this should start pointing to tail. So I will say temp dot previous. Temp dot previous is equal to tail. Great. Once this is done, the tail has to change because temp is the last element now. So I will say tail is equal to temp. Tail is equal to temp. So this is all the code that I have to write to create an element or to add an element at the end of the doubly linked list. So now let's go and write the code inside the main method and check whether it's working or not. So what I will do is I'll remove all these lines. I will remove all the 4 lines. Once I'm done with removing all the 4 lines, now what I need to do is I just have to call the method called as add. So I will create a linked list first. So I'll say new doubly linked list, and after that I need to call the method add. So I will give the name as DLL. Great. I'll come to the next line, and over here I'll say DLL dot add. And after that I need to add the element. First element I would like to add as 5. Next I would like to add as 15. And after that 20. And after that 20. And after that 10. Great. So this is what I would like to add. But now what I would like to do is, I would like to print this as well. But I don't have any method which can traverse the whole thing and print the elements. So what I will do as of now is, I know this is the first element and head will be pointing to this. This is the last element, so tail will be pointing to this. So I'll just try to print the head and the tail and check whether it's giving the right answer or not. So what I'll do is, I'll go to the next line and over here, I'll say system.out.print head.data. Head.data. So if first and last element is correct, then sorry, not head.data. I need to say, I will remove this. I need to say dll.head. dll.head. Now dll.head means it will start giving you the reference of a node. So if I go to inside the doubly linked list, in head it has a data of a node. So basically it has a node. It will print the data of the whole node, but I don't want that. I want only the data part of this head. So what I need to do, dot head is what I have to say. So I'll come inside, sorry, dot data is what I need to say. So I'll come inside and say head dot data. Great. Same way, I want to print the last element as well. That's nothing but dll.tail.data. So I'll just duplicate this line and instead of head, I will say tail. So in case of head.data, I should get 5 and tail.data, I should get 10. If both are working, it means to say that we have written it in the right way. But to cross check, we definitely have to traverse this. The traversing method or the printing method we will write immediately after this. So let me execute this. And if I execute, you can clearly see the first dot data is, so head dot data is nothing but 5 and the tail dot data is nothing but 10. We are working totally fine. So now what we are going to do is, we are going to write a method which will actually traverse the complete linked list and then print the elements of that particular linked list. If you have enjoyed this video and would not like to miss any of our videos, hit on the subscribe button and click the bell icon.